Welcome back. CompTIA Security Plus Domain 2 Technology and Tools. So this part is 2.1. Install and configure network components, both hardware and software based, to support organization support security. So in this sessions, this part, we are going to see this list of components, network security components of firewalls, antivirus software, intrusion detections and prevention systems, virtual private networks, a router, switch, bridge, proxy, load balancers, wireless access points, and then SIM, DLP, NAC, SSL, TLS, mail, media, hardware. So the first one is a router. So the router is a device that communicates between the internet and the device is device in your home that connect to the internet. As this name implies, it routes traffic between the device that the internet. So with the right kind of routers in your home, you may be able to enjoy faster internet service, help protect your family from cyber threat, and avoid those madding Wi-Fi dead spots. So you don't have to be computer genius to know what a good router has to offer. So all it takes it to know what you need it for. Understanding how router works will help you choose the right equipment for your home or corporate environment. So in this picture is you can see is a clear, it gives you clear idea. So it's a very basic idea. This one's the routers, and the sales departments and the account departments are using this to routing the traffic. So the access control list normally is a table tells a computer operating system which access right each user has to a particular system object, such as file directory or individual file. Each object has security attribute that identify its access control list. Zones is a hybrid wireless network routing protocol that has both proactive and reactive routing protocols, where when sending information over the network. Zones routing protocol was designed to speed up delivery and reduce processing overhead by selecting the most efficient types of protocol to use throughout the route. So anti-spoofing is a technique for identifying and dropping packets that have a false source address in a spoofing attack. The source address of an incoming packet is changed to make it appear as if it is coming from a known or trusted source. So there's a formula, simple but useful risk analyze formula. Define risk as risk equal to vulnerability into threat plus into cost. So next is a network switch. So the network switch, a network switch is a small device that centralized communications among several connected devices in one local area network. Standalone Ethernet switch devices were commonly used on home network many years before home broadband routers became popular. Modern home router integrate Ethernet switch directly into the unit as one of their core function. High performance network switch are still widely used in corporate networks and data centers. Network switch are sometimes referred to as switching hub, bridge hubs, or MAC bridge. So in this picture, it gives you a clear idea. So switching security is how do we prevent that? So normally in a network, a switching is a hardware device that filters forward networking packets from one network device, switch router, computer server, etc. To another. It is widely used in local area networks to send each incoming message frame by looking at physical address known as MAC. So actually, a switching is considered as a multi-port bridge that uses hardware address process forward process and forward data at the data link layer of the OSA model. So some switches can prevent process data in the network layer by coming routing functions such as switches, or often referred to the layer 3 switch, multi-layer switch, etc. So the spanning tree protocol. The spanning tree protocol is a network standard as defined by IEEE in the 802.1d standard. The purpose of spanning tree is to prevent loops in the LAN and to select fastest network list if there is a redundant links in the network. In the event that the link in the network goes down, spanning tree will fail over to the alternate link if one exists. If this sounds like what a routing protocol does, then you are on the right track. Routing protocol helps device routers between WAN networks use alternate paths, etc. at layer 3. So spanning tree could be termed a layer 2 routing protocol for a LAN because it's performs the same functions but for an Ethernet networks regardless of IP addresses. So spanning tree is not an IP routing protocol but has something similar functions for the data link layer 2. Then floodguards is one of the features are used to block malicious traffic at the edge of network and prevent it from ever entering an organization internal domain. Example normally associated with the DOS. So next, so bridge. So normally the bridge in a picture, so we can see here the hub. There is a two hub and the middle bridge. The network bridge is a device that divides a network into a segment. So each segment is a separate collision domain with its own bandwidth. Let's say the host A. So you can see the host A wants to communicate with host C, and then host A will send the frame with the host C destination MAC address to the bridge. So the bridge will inspect the frame and forward it to the segment of the network host C is on. The host C is on. So network bridge offers substantial improvement over network hubs, but they are not widely used anymore in modern LAN. Switches are commonly used instead. So this is one of the best example. NATing. So NATing is a network address, stand for network address translation, is a process of changing the source and destination IP address and ports. The main goal of NAT is to limit the number of public IP address a company needs and to hide private network address range. The NAT process is usually done by routers or firewalls. NAT allows a host without a public globally unique IP version 4 address to communicate with other hosts on the internet. The host might be using private address or even address assigned to another organization, which helps reduce the need for public IP version 4 address. As you can see in the picture here, the host A wants to access the server S1 on the internet. Because host A uses private IP address, the source address of this request has to be changed by the router because the private IP address are not routable through the internet. Router R1 receives the request, change the source IP address to its public IP address and sends the packet to the servers on the internet. Server S1 receives the packet and replies to the router's R1, and the router R1 receives the packet. Change the destination IP address to private IP address of host A and send the packet to host A. There are three types of NATing. Static NAT. Translate one private IP address to a public one. The public IP address is always the same. Dynamic NAT. private IP address are mapped to the pool of available public IP address. And then third one is a port address translations, PAT. So one public IP address is used for all internal devices, but a different port is assigned to each private IP address. This type is also known as NAT overload. So okay, network device proxy. So the boundary device between internal and external networks, any device that act on behalf of others, provide security, logging and caching. The proxy server is a block known malicious websites. Forward proxy retrieves data on behalf of your client. Reverse proxy protects access to server on the internal network. Transparent proxy, a caching server that redirect client requests without modifying them to reduce bandwidth. So load balancer. The shifting burden from one to another is very shortened, and so one word is very easy to understand, but there is a lot of types of load balancer around. So the benefit is reduce downtime, maximize the throughput, and allows better allocations of resource. So you can see the distributing load. So the load balance refers to efficiently distributing incoming network traffic across a group of backend server, also known as a server form server pool. So modern high traffic website must serve hundreds of thousands, if not millions, of concurrent requests from user or client, return the correct text, image, videos or applications data, all in fast and reliable manner. To cost effectively scale to meet this high volume, modern computing best practice generally requires adding more server. A load balancer acts as a traffic cop, sitting in front of your servers and routing clients' requests across all servers capable of fulfilling those requests in a manner that maximize speed and capacity utilizations and ensure that no one server is overworked. So which could degrade performance. If a single server goes down, the load balancer redirect traffic to a remaining of online servers. So when a new service is added to the server group, the load balancer automatically starts to send requests to it. So in this manner, the load balancer performs the main three role. So distributing client requests or network load efficiently across multiple servers, and the second one is ensuring high availability and reliability by sending requests only to servers that are online. Third one is to provide the flexibility to add or subtract server as demanded dictates. So different load balancing algorithm provides different benefits, as you can see here. So round robins. So round robin is a request are distributed across a group of server sequentially. So least connections or least time, hash and IP. Hash is a distribute request based on the key you define, such as the client IP address or the request URL, plus optionally apply for consist hash to minimize redistributing of load if the send of upstream server changes. IP hash is also similar. So the IP address of the client is used to determine which server receives the request. Least time or least connections, or least time is a send request to a server selected by a formula that combines the fastest response times and fewest active connections. So and then random with two choices. It picks two servers at random and sends a request to the one that is selected by then applying the least connections algorithm. So this is very scalable, redundancy and flexibility efficiencies. So there is benefits. So network active load balancer is a active and then active passive and virtual IPs. So which means the active means the server work together. So active passive is all traffic sent to active, and virtual IP is at least one physical server and one physical server assigned, but more than one virtual IP address. This is very short and as I explained earlier. So in the picture you can see the software load balancer, hardware load balancers. So how does it perform? Then access point. So an access point is the device that allow multiple wireless devices to connect with each other, just like a hub or switch connects multiple devices together in a single or multiple wired LAN networks. An access point connects multiple wireless devices together in a single wireless or multiple wireless network. An access point can also be used to extend the wired network to the wireless device. A standalone access point provides the same functionality in wireless network which a switch or hub provides in the wired network, and provides connectivity between the different wireless devices. It accepts frame from the connected device and based on its physical address forward it to destination devices. Both the wired network and wireless network use the different network standards. Wired network use the Ethernet standards, while the wireless network use the IEEE 802.11 or Wi-Fi standards. So a device which only understands and supports the one type of stands from the Ethernet stands and the Wi-Fi stands cannot process the frame that is formatted in the other type of stand. So then there is the other one, the multifunction access point. So the multifunction is the combination of the two or more devices. In these combinations, an additional device or are merged with the access point to provide the additional functionalities along with the existing functionality of the access point. A wireless router which ISP used to provide to an internet connection is the perfect example of the multifunctions access point. It consists three devices: access point, regular Ethernet switch, and a router. So in the picture you can see the pure wireless network, how is performing here. So the multifunctions as I explained earlier. So the picture is here. So access points and router, Ethernet switching. So standalone access point. So network device, wireless management and security. So wireless LAN security management service takes your protections to the next level, adding expert support response to a full range of potential data security threats. Most broadband routers and others wireless access points automatically transmit their network name. The service set identifier, usually abbreviated SSID, into open air every few seconds. SSID broadcastings helps it helps clients to see and connect to our networks. Otherwise they have to know the name, set up manually connection to it. So in computer networking, the MAC filtering refers to a security access control method whereby the MAC address is as assigned to each network card is used to determine access to the network. So the bandwidth selections, as you can see, that antenna types and placements, there's two types, omnidirectionals and directionals. So on the right side there's a very brief picture. So this explanation about the standard early BIS 1997 to up to 2019. So how we upgraded how the product upgraded, the security management is upgraded. So the questions. So these conditions exist when data units can travel from a first LAN segment to a second LAN segment through more than one path and is solved by STP. It's a spanning tree protocol. So answer. Answer is looping, D. So the spanning tree protocols at here. So that's it guys for today. That's it guys for this video. So please subscribe my channel, press the bell button. We'll see you on the next topic or next video. Bye bye, see you.